Hello everyone, welcome to my channel. Today let's solve one legal question together. Today's question is number 50 and we need to calculate the power of x, right? Power n of x. So this is a very typical question. What we need to do is to, we cannot just multiply we cannot just multiply x for multiple times. That will cause time complexity of big O(n), right? But that's not the optimal result we want. So here I want to use the recursion algorithm to solve this question. So here we need to take several special cases into consideration. Like when x is equal to 1 or when n is equal to 0. So this is the base case we need to consider. And here we also need to be very careful because n might be negative number, right? So here I want to use recursion to solve this question, and I will only consider when n is equal to positive number. So if n is equal to negative number, we can calculate the version of this n to be positive number, and we will get the, we will use 1 divided by the result to get our final result, right? So let's see. If we want to calculate when our x is equal to 2 and when our n is equal to -2, all we need to do is just to calculate when x equal to 2 and n equal to 2, and we will get our result, which is 4, right? And then we will use 1 divided by 4 to get our final result, which is 0.25. So this is our final result. So hopefully you can understand. So just in order to simplify the questions, I will calculate when n. I will just transfer n to its positive version. I don't know if my expression is correct, but I think you guys must understand, right? So here, first of all, we need to consider several base cases, right? So if our n is equal to 0, which means we just return 1, right? And or our x is equal to 1, we can only return 1. So this is the first base case we need to consider. And otherwise, so when our n is equal to 1, all we need to do is just to return x itself, right? Of course, n can be negative number, but here I just want to, specify, I just want to emphasize, how to say that? I just want to stress here when n is equal to 1, we just need to return x, right? Then we can use recursion to get our result. So I will first, let's see, when our n is equal to 5, we can, let's see, take this as examples for illustrate. Okay, if our x equal to 2 and our n equal to 5, all we need to do is to calculate x equal to 2, n is equal to 2, and then we will use this result. We will just times this result, right? N equal to 2, x equal to 2, sorry. Yeah, and then we will multiply it by 2. So, right? So if our n is equal to 4, this is how to say that, even number, right? Even number. So we can get our result by doing this calculation, right? So here it's very easy to understand. So that means for these two scenarios, we have a common calculation, right? We need to calculate this. We need to calculate this intermediate result for multiple times. So we can just calculate the intermediate result ahead of time, and we will then to get our final result, right? So this is the recursion where we need to do. Yes, and this is x just still x, right? It's still x, and n will be divided by 2, right? We'll get the integer of n. But here let just like I said, I want to treat n to be a positive number, so here I will just get the positive n divided by 2, okay? And this is our intermediate result. So just don't worry that even though we convert n to a positive number, we will handle it. If it's negative number, we will just do more calculations to get our accurate result. So if our n is a even number, all we need to do is just to return res multiplied by res, right? But like I said, n can be positive number or negative number. So if our n is a positive number, what we need to do is return this directly. But if n is a negative number, we will get the final result by doing this calculation, right? Yeah, I hope you can understand. So if our n is an odd number, we can return our result by doing this. Yeah, right? Just like this one, we need to multiply it by an extra x. So this result can be get when n is a positive number. If n is a negative number, we also need to do a transformation, right? So yeah, so that's all. Let's see if the result is correct. Sounds correct. Let's submit our result. Yeah, so that's all for today's question. See you next time. Bye.